Good evening. Good evening. This is Corwin with Watson's Locksmithing Service. I want to shoot a quick video for those who may be scouring the internet or on YouTube looking for a quick little guide or a little information on wiring up a few things. Maybe strike with some push buttons, as well as mag locks or things like that. So what we're going to do today, really briefly, we're going to talk about some of the items that I have. So I am using, that is a HES right here, 1006. Okay, so that's a electric strike made by Hess. It's an ASSA ABLOY company. And then I also have a 5200 series electric strike right here. Now, from the factory, it is shipped as fail secure. And fail secure, and a fail secure installation, what that means essentially is that when power is removed, the lock will remain in a lock position. So what I did was I actually switched this lock, and there's a couple screws that you would adjust on the back, and by adjusting those screws and moving them up, in this case I have it upside down, that will put it into the fail-safe position. Now you have to ask yourself, when you're planning it out, how you want to run it, if it's fail secure or fail safe. In a fail safe condition, when the power is removed, that door is going to remain unlocked. So for the sake of this video, I do have it wired in that configuration, in a fail safe configuration. So I ran these buttons in parallel, and that's one of the things that I was taught, and it was drilled in over the course of training. I actually was trained by ASSA ABLOY, in particular Guy Robinson, who is the training personnel there. Excellent trainer. He during the electromechanical solutions class, which lasted about a week or so, really drilled in. You have to understand parallel, and you have to understand series. So briefly, if you think about it, just to get a visual of a series sort of wiring where there's one after the next after the next, whereas in parallel they are all the same. So in this case, all my commons are tied in together. All my normally opens are tied in together, or normally closed are tied in together, and all my commons are tied in together. So it's not really an electrical class, so I won't go into all of the details of that, but understand, learn, study as much as you can on parallel and series circuits. So again, when I press one of these buttons, which is pretty cool, this strike right now is in the lock position. It's in the lock position. You can't open it up. When this button is depressed, you can hear that button press. You can hear the strike moving. Now, because there's no timer on here, there's no built-in timer, so the strike does not remain open for very long. So I can't do it with one hand. But if I press the button, the strike will open. So again, I wired them all in. I wired these two buttons in parallel. And actually on here, there's actually a little guide, and it'll tell you. So you have your red wire is going, that's 12 volts DC, volts direct current. And then you have black, which they have labeled as ground. And then you have your yellow, which is your common wire. And then you have white, which they have as normally closed. And then green as normally open. So normally open means in its normal state, the button itself, it is that wire that if you were to take it apart, that wire is not connected. It's not touching the other. So if you think about a circuit, right? A circuit has to be completed, wired. You think about it, a circle, right? If any part of that there's a break in that circle, and there's electricity flowing on from one side, flowing throughout the circle, and there's a break, then the electricity will stop flowing. So that would be, in this case, a normally open. Now, if that existed in its normal state, then that's normally open. If it were normally closed, then electricity is always making contact. So electricity is flowing. So in order to break the contact, you need a button or some sort of switch to break that contact. So that would be an example of that would be a magnetic lock that's on the door. So that magnetic lock will have to have some sort of REX or request to exit or button on the side that would be built into your push bar or some sort of switch that you would be able to depress, such as this, that would break the contact. Okay, so in a normally closed situation. So it would open the circuit, therefore disrupting the electricity that is flowing to your device. In a normally open condition, again, the circuit is already open, so you are pressing the switch and it is closing the contact, therefore allowing electricity to flow through. And in this case, it would open your your tab, your release tab, to allow your lock to open. So again, you know, really, there's a lot that you have to consider. But if you don't want to sit down and you don't have to do all of that by yourself, there are individuals who will be happy to do it. We happen to be one. So we are Watson's Locksmithing Service. Again, if you need service, contact us via email at service@watsonslocksmithing.com. You can shoot us a message. We'll be happy to respond and get back with you and talk about your project. You can also call us at 314-287-3630 or 314-281-4752. You can reach me directly. So good luck. Keep studying. And remember that when you're playing with electricity, this is low voltage, so it's for the most part pretty safe. But you still always want to take the necessary precautions and be safe. Oh, and I failed to mention what I'm using to power this is actually a ELK transformer. So it's just a plug-in transformer that I'm using. I actually got it plugged into a surge protector right now, but normally that would be plugged in to directly into your wall, your 110 volts, 20 volts coming from the wall, and that would be delivered to your products here. So these buttons are actually some not very expensive buttons at all. I got these off of Amazon fairly cheaply, and so I have no idea how long they're going to hold up, so I can't really attest to that, but they look pretty cool. That I do know. So I wire those again in parallel. So what that means is too, as well as they become one button. So if they were wired in series, I should mention this. If they were wired in series, then it's one, like daisy chain. It's one after the next after the next. So in order to open the strike, if I had these buttons wired in series, then I would have to press each one of these buttons at the same time in order to open the strike. But when you wire them parallel, they become one button because I tie them both in together as one button. So every cable that extends on here, I did the same on here, and I tied them together, and then I ran them to my power. So again, I would be able to explain that more in detail if you have any questions, but just know that in order for your buttons to work together, they need to run in parallel for the sake of this application or similar situation. They need to work as one button. So therefore, I can have this button in the office, and I can have that button out at a desk somewhere or someone else's office. So then they may be looking at a camera and they can see who's at the door. Then they'll be able to press that button, do it along the wire run, and then open that strike. That's how it works.